Hi, Tim Spann here, Principal Developer Advocate at Cloudera. My talk is the Never Landing Stream with HTAP and streaming. Now, if you're seeing this recorded, I may not have been able to make it live. Sorry about that. Quick introduction. I work with a lot of streaming use cases, big data, fast data, different kind of hybrid use cases all over the world, some involving machine learning, deep learning, IoT, all those sort of things. I run meetups, some in person in New York City and New Jersey, but also usually simulcast online or recorded later. I cover all of the interesting streaming things like NiFi, Kafka, and Flink. Also work with different data stores like TiDB, Kudu, HBase, Iceberg, lots of cool technology. Definitely connect with me. If you have any questions on those sort of things. And if you would like to speak at a meetup, reach out to me and we'll see what we could do. Now, the platform that I'm running most of my open source jobs is Cloudera Data Platform. It makes it easy to run an open data lakehouse, whether it's data engineering, machine learning, data flow, data warehouses, operational databases, Kudu, and I'll show you some interesting things, how I deal with Kudu, as well as some other fast data stores. Again, everything open, portable, run wherever you need to run, pretty easy. Now, the main thing, which the shirt might give it away, if not the jacket, Apache NiFi, that is one of my favorite projects, great open source tool, and I'll show you some of the power for using that for whatever your use cases are. Now, when I'm running in the cloud, I'm using Cloudera's flow management version, which runs it on Kubernetes. Gives me separate designer, isolates things, let me scale it up easier, easier management. But I can also run that standalone on my laptop, and I'm doing that for some use cases as well. And this will let me ingest and manage data wherever it is, edge, on-premise, in the cloud, hybrid, between them. This is really important if, say, you've got, say, TiDB running in a cloud store, and you've got some other data sources and data stores on-premise. I could keep them in sync, move data between them, do whatever your different ways of moving data around, whether it's something like change data capture, or you're just ingesting data and keeping it federated in a couple of places. This is a really strong data ingestion engine, been around for over 11 years. We've got over 400 components to use for processing and ingest, a ton of sources and syncs. A couple of unique features besides the fact that it's all visual. Now you can write your own components in Java and soon Python and deploy them, but for the most part, I'm dragging and dropping and connecting things and having them run either on one machine or a cluster that could be 1,000 nodes large, supporting millions upon millions of events a second, huge. A couple cool features, and I'll show you that while we're going through the demo, is data provenance. So while I'm processing everything, keep a full audit log so you can see everything going on. This is important when you're trying to debug different cloud things going on that it could be hard to figure out what's going on. Also, while you're building your flows, you could see data live and figure out what you want to do next. Also, some things I'd assume you'd really want. Guarantee you get delivery. I get the data. I guarantee you get it. Allow you to throttle or handle back pressure in case systems downstream or maybe slow or offline. Not going to cause any problems. We've got little logs in between them to make sure data doesn't get lost. And it could start and stop at will, including via DevOps. I can automate processing that, which is really cool. We support full development lifecycle. So we've got version control, can move between environments, use DevOps, got a command line interface, an SDK, REST endpoint with Swagger, and a bunch of different tooling, whether in the cloud or on-premise, to move versions up, compare things, lock down everything with security, ton of different sources, ton of different processing to do without having to write any code. Usually we just have to do something like maybe some JSON path, maybe some SQL. Pretty easy to convert data and do some processing. Being able to use SQL for routing data around, as well as transform it from one type to another. Do those both at the same time. And we've got these readers and writers that can read structured, semi-structured data. So things like comma-separated values, JSON, Avro, Parquet, log file formats, things that are reasonably structured. We can process them, let you use SQL against them and convert them on the fly, and I'll show you that. Some of the things that make this really awesome: use the same streaming, doesn't matter if you're on premise, on the cloud, couple of clouds, move between them. Again, a ton of processors. That number keeps going up. I can't keep up with it. And as well, I've created 20 or 30 processors for things like deep learning, NLP, translating file formats using things like Apache Tika, some cool stuff out there. Give everyone the ability to start doing real time. This is not as hard as writing, Flink apps in Java or low-level Kafka processors. This is pretty easy, and we'll show you how easy. Having all the security and governance covering everything. So this covers Kafka, Flink, NiFi, Kudu, everything you have in the Cloudera data platform. One set of open source security and governance makes it easy. One platform, all the pieces you need. Great way to do this. Now, if that was it, that's pretty awesome. But there was a couple of use cases we saw that have very specific needs. And because of that, we created a system called data flow functions. These allow you to deploy functions that act very transactionally. And if you're a fan of function as a service, or if you've used AWS Lambda, Azure Functions, or Google Cloud Functions, you'll see doing these serverless compute is pretty awesome. It's not running all the time, so it saves you money. Just runs when you need it. Can be triggered on cool cloud events. Well, you could develop and deploy these with NiFi as well. We've got a public cloud UI for you. Drag and drop, put the things together, deploy them out to wherever serverless compute you want to use. Pretty awesome. This is built into the open source with some additional tooling out there in the public cloud. This is nice if you want to do something like have file land in S3. When that happens, have it sent to a different S3 object, or sent to Kafka, or sent to TiDB, or some kind of HTAP store. This makes sense. Again, you don't have to worry about scaling. You only run when you need it. You can deploy it in a bunch of different platforms. And there's also ways to run these stateless flows as well on premise. What's nice with this is this lets NiFi run stateful in a cluster that's always running, lets it run on an on-demand scalable cluster in, say, Kubernetes in the public cloud. So you can be stateful but scale up and down, use resources where necessary, or run stateless, run, function as a service, triggered on an event or when you need it to run on a schedule, and run, stop, start, idempotent, something runs and is completed. Very nice, give you all the options of how you might want to run your things. These functions have a lot of interesting use cases out there. Something like you want something triggered based on, say, a file landing in an S3 bucket or some other object store. And the nice thing with NiFi I didn't mention is not just structured data, not just semi-structured data, but unstructured data, which is becoming more important in the days of large language models, more complex NLP, image processing. So something lands in storage, Now, if I can grab a photo, resize it, run different AI on it, get metadata from it, and trigger other things to happen. And only when things arrive. So again, you're not paying for running things all the time. Different kinds of complex workflows based on how things arrive. Say something gets into a Kafka topic, like something went into a call center, something went into SMS, some other kind of notification system. We could trigger events just as they're needed as they happen. We could schedule tasks, again, when maybe things are cheaper or when they need certain times of the day. Have this function triggered and load a whole bunch of data into your database right before people start using it. Great way to do that. Any kind of event-driven microservices. You want to have web applications be able to trigger things without having to run things all the time. Lots of different triggers you can have based on events that happen in the real world. And as part of that public cloud environment, we let you manage all these different types of flows, whether they're stateful or stateless, with a central repository for all these flows. Pretty easy to do. I'll show you those pretty quick. We also pre-built a bunch for you, so you don't have to, think of them. Very common use cases. Something goes into S3, put it into Kafka, vice versa, put it into Iceberg, whatever. Wizards to deploy your things and scale them and set analytics. So you can easily push them into Kubernetes. Dashboards to watch things run. You want to see how things are healthy, put alerts up, that kind of fun stuff. And again, make it easy to run. With the public cloud, everyone gets their own sandbox, so they can't damage anything. Pull things out of catalogs or ready flows to start building visually right away. Very easy to do, and with built-in versioning. Now, because of TiDB's MySQL compatibility, we got full support for it in NiFi. Very easy for us to push records there or pull them out, vice versa. Great way for building applications very easily and scalably. Now, I'm looking at OSS Insight, which is a really cool project out there. And NiFi very easily ingests REST endpoints, and I can push them to Kafka. What's nice is I could send data to multiple things at the same time, and I'll show you how I'm distributing it, going right to a JDBC available database and to Kafka same time, and then I can query it with Flink SQL. Now, another source of data can be TiDB can do CDC to Kafka, and NiFi can process that for us. Kafka is a great way to distribute data real time and spread that between different cloud environments, availability zones, on-premise. Again, works really well with NiFi, so it can distribute data to other consumers of it. And I'll show you a little of that. Kudu is a HTAP store that's available from a Cloudera, and it's Apache project. Lets me do sequential and random reads and writes. I could do time series data, machine data, online reporting. I use it as an IoT store, supports data very fast. And what's cool, it has a SQL layer on top of it, so I could build an Impala table on it and do real-time queries on it very easily. And there's some papers on how it can do OLTP and OLAP at the same time with one open source data store. Now, other options when doing NiFi, using that MySQL API, I could talk to TiDB. At some point, we'll probably add a native connector there. Anyone's interested in working on that, let me know, and I can give you some help and some testing. Now, Flink SQL is another way to do real-time queries on my data, and I'll show you a tool here. Again, no code, just some SQL, point to different streaming data sources as well as non-streaming ones, join them together, do different processing, min, max. Also, I can create materialized views. Having a view that's a REST endpoint with JSON lets me use streaming data in a temporarily cached or most recent version so somebody can read that and see a dashboard in a Jupyter notebook, and as well in things like HTML pages and mobile apps, which I do. Makes a nice way to be able to do things like pass on aggregates, current values, those sort of things without having, these end analytics have to know about Kafka or about how to do consuming messages and asynchronous stuff. Keep it easy for the data scientists, analysts, and end users. Very nice way to do that. Now we're going to create tables from our data really easily. And we're going to run through a demo here. Quick showing you of what we're doing. I'm also going to show you a little peek into a large language model. It is a lesser one from some of the other ones, so the answers aren't the best, but we do what we can. But it's a cool example of how you could do that with NiFi, and how I could take the results of that and maybe push that to TiDB or some other data store like Kudu, and we'll interact with the different data sources. I've got data coming in from the OSS Insight REST API, but I could grab things, and I'm doing that live question and answer from Slack, but I can pull in travel advisories, weather, documents, images, social media, stuff from databases, different REST endpoints, and, send them where they need to go, enrich them real time, send alerts if things aren't right, get them to our different data stores, enrich them, push them out to reports, to Slack channels, all that in real time, whether that's using Cloudera machine learning, Hugging Face, Watson XAI, whatever it happens to be, interacting with different vector databases if I need to, like Solr or Pinecone or Milvus. Pretty easy for us with NiFi. And you can run this at home. This doesn't require some giant data center or expensive cloud resources. There's a community edition that runs in Docker. Does take some RAM, so hopefully you got a decent machine out there. But I can run Flink and Kafka together and do some interesting stuff. And I'm using that for some of the demos, so it's interesting. And for the NiFi part, same piece. Now NiFi can also run on a JVM on your laptop. Whichever kind of environment you're more comfortable with, you can do that. And it's pretty easy to do. With the current version of NiFi, which is 123.2, as I'm talking, the second versions move pretty quick as we're pushing forward to 2.0 with our Python, it is SSL by default and requires a login by default. Too many hackers out there. We don't want people to get in trouble, so we make it easy for you. Let's get into the demo. Hopefully I haven't logged out or timed out from all my resources yet. I have not, so that's great. So I've logged into my public cloud hosted environment just to navigate around real quick and show you some of those things I mentioned. Remember, I said the dashboard for monitoring things. Here's an example of flow running. I could see the system metrics. I could see any alerts, any KPIs that someone sent. I can manage my deployment. This one's on Azure. Pretty easy. I can look at the catalog. I could also search and just find things that are related to my stuff. And if I wanted to grab something from the catalog, I could deploy it into an environment. I can create a new draft, a new environment, download that for local use or to put that in my DevOps system. Like deploying, I could just pick an environment. It could be AWS, Azure, all those kind of fun things. Pick an environment, and then it's going to give me some options. What's this thing here? There's the name of the flow I picked and the version, what environment I'm going to, which version of NiFi. And I can, if I need to go to an older version, I can do that. Lots of different runtimes there. Automatically start when I get there. I can set up a secure endpoint so I can push data in there, and full SSL, full firewall. It requires a lot of security stuff, but you really need to do that in a public cloud. And if I need to put any of my own processors that I've written in Java or soon Python, I can upload those via S3, but I don't have any for this one. And here I could set any parameters I need, like passwords, maybe just, Kafka endpoints, wherever I may be connecting to. And just put junk in there for now. And then I think we have everything we need here. And then we can deploy it, once we have all the data we need. And then we pick the size we want to start with, really small, small. Do we want auto scaling? How big? How are we scaling this based on metrics? And then I can monitor different things, different connections for different parts of the flow. What am I going to watch? And I could do a ton of these, as many as makes sense. Builds my flow deployment over there. Really nice. I'm going to cancel out of this because I don't want to spend all the time in the world just going through a catalog. Remember I said those ready flows? These are ones that'll build the thing for me, fully documented with notes, documentation, everything you need to build a flow. So you don't have to go through that hard work. I want to take Shopify, send it to S3, press a button, set a parameter, ready to go. I've got a flow here running already in an active session, so I can run this locally. And it's a nice way to be able to run a flow without too much work. Okay, just wanted to get through that real quick. Yeah, don't log out. Now, I also have an environment on my laptop, and this one is running integration with Slack, and I'll show you why real quick. Now, I have a Slack channel here where I'm asking some questions here, like how do I use TiDB? So that question went into Slack. That is read in here. As you can see, it's got that question coming through the system. Again, this is how NiFi works. I have that data provenance I mentioned, so I can see what I put in there, what the data is, what the content is, and you can see here, what's going on with this, send it out. I can also take this data and store it somewhere, which may be useful to send it to TiDB. So I receive this Slack message, and then I'm going to reply to it. Now I've got a whole thing that takes that Slack message, sends it to Hugging Face with a FLAN model, and gets the results back. I push it into Kafka. I consume it from Kafka here, as well as other places, clean up the data, pull out just the fields I want here, and then I send out a Slack message, which is just a letter A, and the result here, trimming it, making it nice, sending it to this thing here, and you can see there's the answer. Pretty cool. I mean, not the best answers. Sometimes they're a little not the best. They're getting better as those GPT models improve. Now I'm going to run this once, which is a cool feature of NiFi. I could have things scheduled, like here, constantly run. This data doesn't change too much. Big thanks to OSS Insights for giving us this free data source. So I'm going to run this once. It's going to call that REST endpoint, and I can put all the things in there, whether it's a get or a post, timeouts. Do I need headers? What's my user agent? Do I take tokens? What's my authorization? All those kind of fun things here. You can see things are going on here. We see things as it runs through the system. I can see this latest run here, and it's going through the system here at 10:50. I could see all the metadata. I pulled out a couple of fields that I'm going to want to put in my end data. Tells me start and end date, couple different things there. Interesting metadata. So next thing I did was split the data out. The JSON comeback is 100 different GitHub rows. I want to split those out. That's all it takes to split JSON. Here I do a little query. If you've got more than one GitHub star, I'm interested in you. I take the records that are there now with the fields they have, and add some more that were the metadata that I pulled out, plus a couple things like a user ID. When that's done, I've changed the content itself, and now it's more than what was coming back from the original REST call. So I can update data, do live ETL on it. As you can see, I added some extra fields here, like timestamp, unique ID, the row count from before. And we've got this data in. Again, I can see all the data as it comes in. I could also use this data for testing by replaying it. Could also download it or send it somewhere to be reprocessed. Here I could change any attributes like MIME type. And then I'm going to send this to Kafka. We're going to take the schema, just send it as JSON. Pretty easy, no code here. Don't care what the fields are. It handles it for me. Send it to this topic with those brokers. Those are my parameters, which I could change based on where I am. And then I could see if it made it. It did make it. So we got that data there. Let's just check here, make sure I got my data. And as I can see here, I've got 100 rows here, over 100. So this is run. And I can see I put in a bunch of different Java repos that had more than one star. Again, we can put it as many as we want. And if you look here, I'm running a Flink query against that Kafka topic. Maybe here I'd want to do something like if the number of stars is greater than a certain amount, maybe insert that into another topic or insert that into a data store. Pretty easy. Thank you for coming to my talk. I hope you enjoyed it. If you have questions, definitely reach out to me. All my contact information is here. I'm on Medium, GitHub. I'm on Twitter. I'm on LinkedIn. Reach out. Thanks for coming to my talk, and hope that your stream never lands and it's always running with streaming. Thanks again.